Students have a little confusion about the AC and DC generator. Today our focus is on AC generator. Let's talk about this. First, what is generator? A generator is an electrical device based on principle of electromagnetic induction that converts mechanical energy into electrical energy. Here two points are involved. Number one, it is based on the principle of electromagnetic induction, and number two, it converts mechanical energy into electrical energy. Now how AC generator is made? I want to show this with animated diagram. Let's say this is a magnet. A magnet is the basic component of AC generator, and AC generator consists of a magnet which has concave pole, and the poles are facing each other, and magnetic lines of force passes from north to south pole of the magnet, and a coil is placed in between these two poles, and this coil means hundreds of tons of the insulated copper wire is made around a rectangular bar, and rectangular bar acts as core, but hundreds of tons are made around it. The four corners of coil can be named as ABCD. Its two terminals are connected to the ring. One of the terminal is connected to one ring, another terminal is connected to another ring, and rings are named as R1 and R2. This component, I mean to say the coil and the ring, they both rotate around a common fixed axis. Now each of the ring is connected to a brass, and it is named as B1 and B2. These are two brass. Brass keeps on pressing the ring, but they do not move. If current comes to ring 1 and ring 2, they can be collected by brushes B1 and B2. And these brushes are connected to the load. I am making only one load just for representation only. It means R1 and R2 are slip rings, and B1 and B2 are the brushes. Okay, now let's talk about its working, how it works. The coil is rotated this way. Let's say the coil is rotated in anti-clockwise direction, and if it is rotated in anti-clockwise direction, then AB goes down and CD goes up at this time. And in half of the rotation, what happens? AB cause of the magnetic line of force passing from north pole to south pole of the magnet, and CD also cause of the magnetic line of force passing from north pole to south pole in half rotation, but CD cuts the magnetic line of force in the upward direction, and AB cuts the magnetic line of force in the downward direction. And whenever magnetic lines of force are cut down by the coil, then EMF induces into the coil, and we can get electric current. Motion of CD is in upward direction, AB is in downward direction in half of the rotation. If we are moving it in anti-clockwise direction, the direction of the field is same. In both the cases, it starts from north pole of the magnet and ends to south pole of the magnet. Now we can declare the direction of current. If motion is in upward direction in CD and field is in right hand side, then certainly current moves in this direction. I mean to say current flows from D to C according to Fleming's right hand rule. And on the other hand, in AB, what happens? According to Fleming's right hand rule, current moves in the direction BA in the side AB in half of the rotation. It means direction of current is DCBA. If it comes to the terminal A, then certainly terminal A is connected to the ring R2. Current comes to R2 and is collected by brass B2, and it flows from B2 to B1. This is the direction of current in half of the rotation of the coil. Now what happens to remaining half rotation? I mean to say when AB cuts off the magnetic line of force, again it comes back in the position of CD, and CD goes to the position of AB. We can understand this way. Now AB comes to the position of CD, and CD comes to the position of AB this way. Again the same thing happens. I mean to say CD cuts the magnetic line of force towards downward direction, but AB cuts the magnetic line of force towards upward direction, and field is same. So current flows from A to B in right hand side, but from C to D in left hand side. This way direction of current will be A, B, C, D. If it is so, then the terminal D is connected to R1. Here we can understand at this place also terminal D is connected to R1. This is the connection. In the same way here also the same thing we have to show. D is connected to R1. That's why current comes to R1 and is collected by the brass B1, and when it is collected by B1, then it flows this way through the bulb. It moves towards B2. It means the direction of flow of current is now B1 to B2. This is just opposite of the previous. Previously it was flowing through B2 to B1, but now it is flowing through B1 to B2. What I mean to say, in half of the rotation of this coil, current flows from B2 to B1, but in another half rotation, current flows from B1 to B2. In this way, direction of flow of current keeps on changing, and this is the characteristic of alternating current. And this AC generator is designed in such a way that the coil rotates 50 times a second. It means if it rotates 50 times a second, then 100 times a second direction of flow of current keeps on changing. And the same is supplied to our household circuit, and it is called the alternating current of 50 Hz frequency. It means in generator, coil is rotating 50 times a second. Because of this reason, direction of flow of current keeps on changing 100 times a second. Thus AC generator works. Okay, now I want to stop this.